Hi everyone, my name is Milad and today I'll be doing a system design practice exercise. I am doing these to help improve my skill set, but I hope in that process you guys learn something as well. Remember to always double check anything you see and hear in my videos. There are people far more experienced and fluent in system design than I am. If you do enjoy the video, please consider liking, subscribing, and leaving a comment. With that said, let's dive right into the exercise. Today, I'll be designing a multi-engine virus scanning service. The requirements I will try to satisfy are as follows. Allow users to upload one or more files at a time. Scan files with multiple antivirus engines for thorough detection. Store and display scan results in a public database. Send real-time alerts for detected file threats. Allow users to create account for scan management and history. Great, so this looks like we'll be storing a lot of data and we'll need a lot of block storage. Block storage is basically big binary object storage that will store all these files. Additionally, we'll be using a lot of bandwidth and we'll be doing a lot of scanning using different engines, so we'll definitely need specific engines that utilize different types of antivirus engines. Alright, and we'll definitely need to manage accounts and allow users to view past and current activities. As always, I like starting off with a database. In this particular time, for this particular system, I feel comfortable with using Postgres or MySQL. I'll use Postgres because it provides better scalability and is designed and geared more for systems that are operated in the cloud based on my understanding. So we'll be working with tables and columns, and we'll start off with the user table. We'll have user ID, username, password, email, and other metadata that we feel would be appropriate. But I'll limit it to just metadata. And then we'll be tracking people that will be uploading the files that each user will be uploading. And remember that not all users will have account. You can't go to the service and upload a file without having to create an account. So typically I would name this, if sign up was required, I would name this user file, but because it is not dependent on the user table, I'll just simply name it uploaded file. We will have an uploaded file ID. We will have file type ID. This will let us know what type of file we're dealing with. We will give it a status ID. We will give it, let's see what else we need. We definitely need the URL where this file is stored. Date stamp, and that will give us enough information. And obviously you can always have more data here depending on what metadata is important to you. We will also have an optional user ID, which can be null, meaning that it is not associated to any user, but that possibility is there. Next, we will have uploaded file scan. Once again, we will make this we can make the primary key the uploaded file ID and the virus engine ID, letting us know what engine this file was scanned. Remember, our library of virus engines can grow and shrink, And as a result, we'll have a one-to-many relationship, and this gives us that normalization we need for that. We will have status ID, date stamp, and any other data we need. Status ID will tell us if it started, completed, and whether it has detected any viruses. Let's take a look here. Now we need, I'm trying to see if we need anything else. Let's see. Allow users to upload multiple files at one time. Scan. Store and display scan results in public database. Send real-time threads. Blah, blah, blah. All right. So that looks pretty much like the very basic elements we need for our service. Next, we need to identify what our API will look like. And first thing we will have is a post, and this will be user sign up. We will provide a user name, email, and password. It could either just be an email password. That really depends on how you want to approach this. Next, we will have another post, and this will be user login. And if you want to use, let's just use email here and password. Next, we will have, just come here, make sure I'm consistent. We will have another post, file, upload, and we will have number of files. It could be one or many. In addition to that, we will also pass the access token in the header. This will be in the header. An access token is basically a value that's sent back and forth between the client and the server that allows us to authenticate the session and make sure it is valid. Next, we want to do a get. And we will forget we are getting file list. And this will return a user's files. So we will, in the header, we will pass the access token. And that will return to us a JSON that contains all the list. Next, it talks about managing. So we might want to, I don't know, let's just say for the sake of demonstrating this, we can do file delete. We will have a file ID, and once again in the header, ensuring that we are authorized and own this file to delete it, and this will return to us a success or a failure. All right. So let's just take a look at here. Here, let me just stress some additional data points. Results will be a JSON, and that JSON will let you know if, let me see here, because we're doing multiple, this will be, okay, so we will go to a page where we will see all the virus engines that our service will provide. Oh, which reminds me, here, what we're missing here is the virus engine table. We will have a virus engine ID as our primary key used to identify rows here. And then we will have name and status ID and other metadata, and maybe a date stamp. We will also allow, okay, so this is a good start here. I think we can start with this and then see what else we need to do. As with any service that's available throughout the world, we'll always start off with load balancers. And load balancers help direct requests to the most appropriate regions, and those regions will help direct you. We'll have a regional load balancer, and regional load balancers are designed to help direct your request to the most appropriate data center, where you will hit an API gateway. And the way these load balancers direct your requests is really based on what makes most sense for you and your users. There are many ways you can approach this: round robin, least load, fastest response time, least latency, weighted round robin. And one of the reasons you might use weighted round robin is because maybe some of your data centers have more powerful and more recent hardware than some other data centers. The reason you want to also distribute and have multiple data centers is because if there's some sort of natural disaster or some sort of issue, you can still have your service up and running because other data centers can pick up the request that other regions can't. So we will now, once we hit the API gateway, we want to validate and authorize the user. So for that, we'll have an authorization service. And what this authorization service does is it looks for an access token. It then validates that access token, ensuring that it has not been modified. And then it looks into the cache to check so what we do is we first validate the access token. We then take the user ID that's saved in that access token and we check whether that user is still active and exists with our system. It should. And the fastest way to do that is, instead of hitting our database, which will have our user table, and it will be once again, just a quick reminder that we're using PostgreSQL here. So It will first check to see if that user information exists within our cache, and if it doesn't, we'll hit our database. Now, the reason we want to use cache is because it has really fast response time, meaning hitting a Postgres database service can be fast, but it's nowhere near as fast as taking that data and saving it in cache. And the reason you save it in cache is for fast latency, and the reason you save it in a database is for longevity and long term, because cache typically is cleared when the service is restarted. Alright, we then have a user service. And the user service allows us to sign up. When a user signs up, the request is routed to the user service, and then upon a successful registration, that information is saved into our database as well as saved into the cache. Next, we want to upload a file. When we're uploading a file, we want to make sure we want to first direct the request to upload service. And that will immediately take that service and save it into a blob storage. And once it's completed, it will write to a message queue. Now, a message queue is a service where you publish specific messages. And these messages can be related to anything, and you can categorize those messages into topics. And those topics can then be subscribed to what are consumers. Consumers are typically services that are interested in those topics because they take that information and perform some sort of operation on it. One common messaging queue service is Kafka. So, we will then have many services here. For each specific virus engine, we will have a designated virus engine service. That will, each one of those will be in its own consumer group. And a consumer group is basically consumers categorized into their own groups so you know who is consuming that message. And you can have multiple consumers in a single consumer group, but there's a correlation between how many consumers you can have and how you've partitioned a topic. what partitioning a topic means is if you have a really popular topic that gets a lot of messages and a single consumer cannot process all that information fast enough, you break up that topic into individual parts, and for each partition you can have a designated consumer read from it. There's a one-to-one correlation between partition and consumer. So if you have a topic with two partitions, that means there can only be two consumers from one specific consumer group that can consume the messages from that topic at one time. And because we want to make sure that we are scalable, this is why we will have each virus engine be wrapped in its own service so that we can scale that up and down and partition it accordingly depending on the process intensity and the volume. Once these virus engine services finish scanning the files, they will write the results to another topic. Scan results. Once again, another Kafka service. And on the other end of that, we will have consumers consuming that. In this particular case, we will have result service. And the result service will consume this information and then write the results to our database, as well as write it to save it to our cache. So now we have uploaded a file, we've processed and scanned each file with different virus engines. We've then stored the results of those in our database and in our cache. And we will now make that service available to make that information available to users. We'll name this one file result service. When a user goes to look at their files, they will hit the file result service. We can just call this file service, and it will check the cache to see whether the results are there, and if not, it will then look in the database. That allows us to now provide detailed information about not only the files that have been uploaded for a specific user, but all files based on specific settings. Now, because we want to allow users to upload files that are private, what we can do is have another setting here called private. And this will be a binary value. If it's on, it means the files are not accessible publicly, and if it isn't on, it will let us know that we can make that results available to the rest of our user base. Now, one thing we want to do is send real-time alerts for file threats. We haven't taken care of that right now, and we'll address this now. So when a user is uploading files, what happens is after they finish uploading the data, they'll be redirected to a scanning page where it will show what engine is currently scanning the results and what the results, scanning the file and what the results will be. So there are two ways we can approach this. We can use a WebSocket connection that continuously sends updates to the user, or we can do long polling. Long polling is basically having a connection to the server that waits for the server to respond before either closing or sending that information back. Whenever we introduce additional technology or additional services, we are providing a level, we're increasing the complexity. And whenever you increase the complexity, you increase cost, failure points, and many other issues and overheads. But in return, you provide a better user experience and more features that your competitors might not. So here, we would say that once you go to the scan status page, we create a WebSocket connection. Now, WebSocket, once again, is a communication that's bi-directional. The client and the user, the client and the server will communicate with each other, sending information back and forth continuously. Once a WebSocket connection is established, that information, the user's connection information, is saved into our cache. So that our system knows how to send responses back. Then what we do is, while the virus engine is scanning, we will have additional subscriber here. That will continuously read from this topic and communicate the status to the user as the virus scans are going on. Let's take a look at our requirements. Allow users to upload one or more files. We've addressed that. Scan files with multiple antivirus engines for thorough detection. We've addressed that as well. Store and display scan results in a public database. That is possible unless a registered user has requested that a file be private. Send real-time alerts for detected file threats. We've done that, as the engines are scanning, we're updating on the progress and the status of those scans. Allow users to create accounts for scan management and history, and we've done that as well. It's worth noting that you can also utilize OAuth for allowing users to register without having to go through your in-house registration process, and instead use something like Google or another service to provide the access token that you need to authorize them. Alright guys, this is my attempt at designing a multi-engine virus scanning service. Please let me know if there's anything I missed, or if you have any suggestions on how to improve this. I'm always looking to grow and improve. Until next time, thank you so much, and if you did enjoy this video, please consider liking, commenting, and subscribing. Take care, and happy holidays, everyone.